Hello. For today's lesson, we're going to look at linear systems, but the particular task we're going to work on is not solving linear systems or graphing linear systems to solve. We're only going to focus on this video on just actually writing the linear system. So in other words, we'll be given a paragraph that describes a certain system situation. Our job will be to translate the information from the paragraph into the math language so that we can create a system that we can then apply our mathematical techniques to solve. So this video is not going to focus on the solving part. It's just going to talk about how we can take a question and write it into equations. So the information I see here starts with the question itself, like what is being asked for. The first thing that you need to do in order to write equations is you need to have variables defined so that you can write equations with those variables in it. And the rule is, almost every time I've seen a linear systems question, the last sentence of the paragraph is the question of the thing that you're trying to find. So they tell you a bunch of information, and at the end of the paragraph, this is what they want to know. How many multiple choice questions and true-false questions are on the test? So I can take that sentence and turn it into my variables because M represents the number of multiple choice questions. Notice M does not represent the number of points for multiple choice questions, it just represents the quantity. How do I know that M represents the quantity? Because that's what we were asked to find. How many, not how much points is it worth, because we already know that from the paragraph. T is the number of true-false questions. Then, when I read the paragraph, the first thing I notice is there's 20 questions. That makes it real easy then, because if I actually define my variables as the number of multiple choice plus the number of true-false should total 20 total questions. The next one requires a little bit more thought, but it's not that much more difficult. This time now, instead of talking about the number of questions, we're talking about point value. So right here we see that the total test is worth 100 points, and then what I get is rates of change. There's 3 points per question on true-false questions, and there's 11 points per question on the multiple choice. What you got to do, or what you have to do, is to learn how to read those paragraphs and identify what are fixed rates versus what are variables. What's variable is the number of questions on the test. What's fixed is the rate of value for those questions. So when I see 3 points per question, then if I multiply that by the number of questions, we can do dimensional analysis and show that questions divided by questions is 1, and I'm left with 3 times t points. Similarly, we have 11 points per question on multiple choice times m questions adds a total of 11m points. So let's be clear about this. If there were 5 true-false questions, there would be 15 points, 3 times 5. If there were 10 true-false questions, that would total 30 points, 10 times 3. Similarly, if there were 5 multiple choice questions, that would be 55 points contributing to the test. If there were 100 multiple choice questions, then there would be 1,100 points available. So we could see that if we multiply the number of questions times the points per question, that gives us the total points available. What we know is we need 100 points on the test, which is combining both true, false, and multiple choice. In other words, we need 100 points total. If we added 3 times t questions plus 11 times, points plus 11 times m points, we should get 100 points. This creates then 2 equations with 2 unknowns. There's a whole bunch of ways that we can add up 2 numbers to get 20, and there's a whole bunch of ways that we can get 100-point tests. But there's only one way that both of these things can happen simultaneously. That's the question that we're trying to answer. So the real skill in this chapter is to be able to take a paragraph like this and very clearly and succinctly write a system that can be solved. Now that we have the system, we can graph the system and predict where the solution should be, and we could also use substitution or elimination to get the actual solution once that's done. We'll work on that later. Here's another question, similar design. And so what I train myself to do is define my variables first, and in order to know what I need to define, I go to the how many. It says how many of each design should be ordered. So I see what's happening here is a restaurant manager is purchasing dishes. There's 2 different kinds of dish sets, and so what I'm trying to find out is how many of one kind and how many of the other kind need to be purchased in order to meet the criteria that are established up here. Since the question is how many sets, then I know the number of sets is the variable for cheap sets and for expensive sets. So I've defined A as the number of cheap sets and B is the number of expensive sets, and I'll even color code them there. And now I know that A plus B is going to equal 20, or 200. How do I know that? Well, it says we want to order 200 sets of dishes. If I take my cheap sets, add it to my expensive sets, I need to have 200 sets total. Once again, there's a whole bunch of different ways that I can make this combination. 100 and 100, 50 and 150. This could be one set, this would be 199 sets. But no matter what, we have to have 200 sets total. So that's the first equation. Lots of solutions to that equation. Now, the second thing I do is I look for rates. There's always going to be some sort of rate of change here to convert your variables. So $25 per set. You see the word per? That's a rate. 25 per set. And so I could say $25 per set times A sets gives us 25A dollars. So again, dollars per set times set equals dollars. Similarly, $45 per set times B sets gives us 45B dollars. The other information from the paragraph then says that if we had spend all the money, it'd be $7,400. So the dollars spent on cheap sets plus the dollars spent on expensive sets has to total $7,400. In other words, this has to be true. Now, it's important when we look at our equations in these systems that we can look at the numbers, the coefficients, and see if there's anything that can be divided into them, because we would like to work with smaller numbers if at all possible. So I see 5 and 45 are both multiples of 5, and so is 7,400. So I'm going to reduce everything by dividing by 5. That gives me a nice clean system to solve right here. Once again, how I solve it, that's going to be the next step. But the first two steps of the process of doing these kinds of problems is define your variables and use those variables in two unique ways to create two unique equations to generate a system. So what I'd like everybody to do for homework would be to, oh, not this. This looks like calculus. Here we go. This is in the handouts that you have. These are 8 different systems style equations, and for the next time we meet in class I would like everybody to go through all 8 of these and just write the system of equations that results, showing all the work of course that I did here, but in each case we should end up with 2 equations and 2 variables. Later on when we meet up again next, we'll work on the actual solving of them. They're going to have to be solved eventually, but for now spend your time concentrating on writing the equations. Thank you.